Now we can talk about slope-intercept form, in other words, y equals mx plus b form. The equation of any line can be stated in several different algebraically equivalent forms. We could have x and y on the same side, or solve for x, or solve for y. These algebraic changes don't change the underlying mathematical information. No matter how we rearrange the algebra, it's always the same line that's represented. That's an important idea. Of all possible algebraic representations, mathematicians have selected one as particularly useful. If we solve the equation of a line for y, getting y on one side by itself equal to everything else, then we automatically put the equation into what's called slope-intercept form, or y equals mx plus b form. In this equation, y equals mx plus b, m is the slope of the line and b is the y-intercept. If we solve the algebra for y, we automatically get these two very important quantities, the slope and the y-intercept. We can see that m must be the slope because when x increases by 1, y has to increase by m. We can see that b must be the y-intercept because if we set x equals 0, then y equals b. It's easy to put any equation into slope-intercept form, and once it's in that form, it's easy to understand where the graph will go. Starting from the y-intercept, we can take slope steps that we discussed in the slope lesson. 1 unit to the right, up m slopes, or 1 unit to the left, down m slopes, etc. Here's a practice question. Pause the video and then we'll talk about this. Okay, find all the points jk on the line y equals negative 4/3 x plus 2, such that j and k are both integers with absolute values less than or equal to 10. So this is in y equals mx plus b form. The slope is negative 4/3. The y-intercept is positive 2. And so that's the point 0, negative 2. So that's actually one of the points. That's one point that satisfies this condition. Both the coordinates are integers, and they both have absolute values less than or equal to 10. Now, what does a slope of 4/3 mean? Here we're going to take the numerical perspective on slope. Slope means move right 3, down 4. Or it could mean move left 3, up 4. So if we start at the point 0, 2, then if we move right 3, down 4, we go from 0 to 3 and down from 2 to negative 2. If we go right 3, down 4 again, we'll get to 6, and then down 4 more, down to negative 6. Right 3, down 4 again, we'll get to 9 and negative 10. So we have to stop there because we've reached an absolute value of 10. But all of those points work. Now go back to 0, 2. Now we're going to go the other way. We're going to go backwards 3, to the left 3, and up 4. So that would bring us to negative 3, 6. And then again, negative 6, 10. And we have to stop there because again, we've reached an absolute value of 10. And so there are 6 possible points. Here are the 6 possible points that satisfy this condition. They're on that line, and they have x and y coordinates that are integers, and both the x and y coordinates have absolute values less than 10. Here's another practice question. What is the slope of the line with the equation 3x plus 5y equals 8. So that's one way to write it. So all we have to do is solve for y. So we're going to start here. First, we'll subtract 3x from both sides. Now we're going to divide everything by 5. Remember, when we divide by 5, all 3 terms get divided by 5. And so we get a slope of negative 3/5. In fact, we also find out that the y-intercept is 8/5. That wasn't asked, but that information is kind of tossed in as a bonus. Notice that horizontal lines have a slope of 0 because they are all run with no rise. If a horizontal line has a y-intercept of negative 4, then m equals 0 and b equals 4. And so the slope-intercept form for this line would be y equals 0 times x plus 4, or in other words, just y equals 4. The default form for a horizontal line can be interpreted as a kind of slope-intercept form. It's what happens when slope equals 0. Now, vertical lines are very different. First of all, because vertical lines have undefined slope, because the slope fraction is always something over 0. So you could say they have infinite slope or undefined slope. Furthermore, vertical lines run parallel to the y-axis, and typically they never intersect the y-axis, except for the y-axis itself. Any vertical line that is not identical to the y-axis never intersects the y-axis. So the standard form for vertical lines, x equals k, is completely unrelated to slope-intercept form. It's its own thing. Here's a practice problem. Pause the video and then we'll talk about this. A couple of videos ago, we talked about how if you were given the x and y coordinates, the x-intercept, the y-intercept of a line, we could find the equation of the line. And that's exactly what this problem is asking us to do. So first thing we're going to say is we're given the x-intercept, so we know that. We have a little slope triangle drawn right here. It's formed by the axes right here. And we have a run of 5 and a rise of -2. And so we have b equals 2, a rise of -2, a run of 5, and we get a slope of -2/5. So now we can write the equation of the line, y equals mx plus b, y equals -2/5 x minus 2. All right, very good. But now we go back to the answer choices and we see that's not listed. We have integers times x and y, and the x and the y are on the same side of the equation. All right, so how do we do this? Well, first, we're just going to multiply everything on both sides by 5 to get rid of the denominator. So we get a 5y equals -2x minus 10. Then what we're going to do is add 2x to both sides. So we get 5y plus 2x equals -10. Now we go back to the answer choices and we recognize answer choice D. In summary, if we solve the equation of any line for y, we automatically put the equation into slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. This form makes it easy to graph the line and understand where it goes.